This video, we're going to demonstrate some plate design and cutting with a plasma table. We are going to make a mount for a chassis jig, and we're going to be replacing a 3D printed prototype. We're going to be welding chassis. The new metal plates will be heat resistant. ADS can be downloaded from the website armaautomotive.com. If you scroll to the bottom, there's a link for Arma Design Studio, CAD CAM software. And there are download links for Windows and for Java, which will run on Mac, Windows, Linux, and other Java supporting platforms. ADS can generate G code that will operate CNC routers, such as this buildyourcnc.com. It's a wood frame CNC router. It's controlled with a Mach 3 compatible controller board that will work on any computer. Mach 3 or Mach 4 are affordable control software. These you can buy as a kit, you can assemble it, and this one, they have a few different sizes. This one's 4 feet by 8 feet, a bed length, and I think the height is 4 or so inches high. ADS also will generate export G code that will operate the Langmuir plasma table. They have a couple of different sizes. This one I believe is 3 feet by 4 feet, and this is good for cutting metal with a plasma torch. So with one of these and air compressor, you can cut plate metal. Langmuir uses their own control software, and the G code that ADS exports with the option is compatible with this table. This plate demo is recorded on ADS version 1.2.40. Plates are drawn in ADS with polygons. They can be added to the scene by clicking on this polygon tool, which is an icon of a square and a triangle. So in order to generate a polygon, you can double click to set the initial number of points and the shape that they will form. So polygons, we just want straight edges. That's how they'll be cut. 4 is just the initial. Now if I click and drag, I can create a shape. It's going to generate this square, and then I can click on the move tool, and I can move this around. If I double click, I can open it in the editor window, and I can adjust the geometry. I can also add more points. I can also remove points, and when I'm happy with the changes, I can click OK and bring them back into the main scene. So this shape will define a path that a tool, the router, or a plasma torch can follow. In the file list, I'm just going to call this demonstration plate. If I want to cut features from inside of this plate, I can add a new polygon, click, drag, and release. And this is going to be a hole. And I'm going to click the object in the list, and I'm going to drag it into the outer plate. So when I click on this plate that contains a child feature, if I drag this around, it will stay. If I rotate around, it's on this roughly on the same plane. I'm just going to click on the front view so that I'm on the straight plane. I'm going to add a few features. I can copy and paste to create another one, or I can copy and I can click on the main plate and paste as a child and give it a new number. And I can move, I can click Command and an arrow key and move these features, or I can click and drag. I can click Shift, click and drag, copy, right click, I can copy, and then in the parent I can paste again. This one's going to be 4. And then I can shift click and drag, and this plate will cut these four features first and then cut the outline. So if I want to generate the code for this, I'm going to save this file, plate test, save the file, and under CAM, export plate cut G code, this menu will pop up. This will also likely require an account with manufacturing 1. So if I click on export plate cut G code, it's going to bring up this dialog. There's an option for router G code or plasma. Order by object size we won't be using in this example. And this is probably going to be removed, margin inset, outset, and that will be a manual process. This is going to be the kerf width is either the drill bit diameter or the width, the diameter of the plasma torch cutting the material that's removed, but this won't be used in this example. We are just going to leave the default settings and click OK. Then we will take a look at the G code later. These plates can be quick. It's a quick way to draw plates, but there's no easy way to dimension these shapes. Plates are exported on a plane. The geometry that's drawn has to be oriented on one of the three axial planes. So here's an example. Each of these polygons represent a plane. So if this shape is rotated and I export, it's going to project it onto this plane, but it's going to be dimensionally incorrect because it's going to project to a flat plane. So one way to solve this, if you want to model a plate in your design, is to select the features and click on the CAM layout view. So by default, modeling view renders all of the objects in the 3D scene as they exist in the part that you're going in the completed part. Layout view allows you to set a alternate coordinate system or an alternate location so that the parts can be cut on a flat plane or in an orientation that your manufacturing tools will support. So if I'm going to click layout, and now that these features are rendered in layout view, you can tell by this asterisk after each of the markers. So now I can select these features and I can rotate them to meet with to orient them along one of the planes. So I'm going to rotate so it fits on the plane. Actually, maybe I'll rotate it so that you can see the difference. I'm going to rotate it flat so that it would simulate sitting flat on a table. And this is how it will sit on the cutting router or a plasma table. And then with the object selected, I go back to modeling view, and then they go back to the 3D representation. This will allow you to construct your models with parts fitting together, but then lay them out separately. You can also nest them and pack them on a sheet, depending on how big your manufacturing tools are. One of the options for plate cutting is setting the order. And if you want to, under CAM, there are these two options for enable, disable, and this will basically let you disabling a part will maintain its visibility in the scene. It just won't be exported. So some features you may want for rendering purposes, but you don't actually want to cut. Select the poly order will let you choose a number so that you can decide which order these features are to be cut. In some cases, if there's a lot of material removed from a part, there may only be a small amount of material holding the rest of it on, and you may want control over which pieces are cut so that you can cut a smaller piece and then cut a larger piece later, just so that you have control over how much material is connecting the remaining metal. Modeling with polygons is quick, but it's difficult to define distances. It's tedious to do that. So an alternative method is to import a 3D mesh object from another CAD application, or to use Boolean modeling tools, generate the cut profile based on the edges. Make a new project. So a demonstration of how to make a plate cut profile based on an object. I'm going to make a plate and I want some holes in it, so I'm just going to use this cube. I'm going to drag it, I'm going to click edit, and I want this cube to be 2 inches wide, 2 inches high, and 1/8 inch deep. So I'm going to click those options. If I hit option and drag, I can rotate the part around. I'm going to name this in the list plate. I'm going to view this from the front, and I'm going to move this plate to the center by X and Y, so it's sitting in the center. And I want some holes, so I'm going to click drag and release a rectangle. So I want a 1/2 inch hole. So what I'm going to do is click on the edit, and this is the radius. So I want 0.25 inch radius, make it shorter. I'm going to rotate on the X 90 degrees. Let's just give this a different color for now. And I'm going to set the location to negative 0.5 and 0.5 and 0. Now you can see this this whole cylinder is protruding through the plate. And now in the plate, I want to cut this cylinder from the plate. So I'm going to use the subtract menu, the subtract folder, and then I'm going to drag the cylinder into the subtract. And I want a few cylinders. So I'm going to click copy and in subtract, paste as child. And let's say this one, 2. Let's move it over. And it's going to be rendering the generated object in over top of the transparent original source. So I'm just going to hide this for now. Right click, hide. It just makes it easier to see. You can still click on the original plate and you can still change the properties. You can still let's make it bigger. And then the shape will update in time. Let's make some new. Let's make some new. Let's do 3 and then negative. And we'll just leave it like that. Now we have this Boolean plate demo is an object that's constructed based on the objects that you apply to the original plate. And this is, if we've modeled this and it's a representation of the part that we want to cut out of a plate, what we can do is click on the tools, plate, object to outline. And it's going to generate a new feature. That one didn't like that one. But we can fix that by selecting of these and putting it in manually. The Boolean tools for managing this does generate invalid geometry in complex scenes. So one of the edges in this object failed, but we're just going to create the replicate the failed edge from the odd geometry, and now we can generate the G code for this. I'm going to save the file, like boolean test, okie doke, and I'm going to click generate the plate. We're going to cut it with plasma. So an example of an actual part that we're going to make. This is a part that I'm going to manufacture. I have a prototype stand for our chassis jig made with ABS plastic with a 3D printer. And we made the shape so that we can test the fitment to figure out what we want. And now we need to make it out of metal because the plastic will melt once we start welding the steel frame. So this stand is made from two pieces of plate metal, and it is two parts, a vertical and a base plate. The vertical is made from a rectangle with a hole cut out the bottom that makes for teeth, and then the hole for the tube. So I made the cylinder the radius of the tube, and I subtracted it by half of the kerf width from the plasma torch. I'm going to click on the shape, and I'm going to generate plate, object to outline. It's going to make a new object here. I'm going to hide the other shape, and now I can generate the G code for this shape and cut it with the plasma torch. I'm going to do the same for this base plate, and the idea is the base plate has holes for the tabs, and it has 6 holes for the bolts. So this plate is going to fit on an 80-20 rail. It can be fit uh, lengthwise or along one of these edges. If you don't want to model your geometry without the kerf compensated, you can also use this experimental feature under Tools, Plate, kerf in and kerf out. These are experimental. They will fail in some cases, so this is a work in progress. These will basically expand or contract um, the geometry so that it will be one half of the kerf width that you enter based on the units. It will also add a it will also add lead in and lead out start and end points so that when the plasma torch is initially uh, piercing, it takes a small amount of time in order for it to ensure that there's an arc, and that can create a hole in the part. It's a good idea to outset that so that the hole happens outside of the part. If I go to edit, I can see, and I can also manually edit these lead in, lead out. But the G code generated will start here, run through the part, and then end. So one of the parts that we're going to be also making are plates for the Jeep front bumper. So we have a few different plates. There's a base plate that mounts to the chassis that has holes for bolting, and it has slots for these other plates. And there are other CAD applications that would be probably better on their own for generating plates, but the value of having a plate in ADS is because ADS has these arc tube features that can be notched and bent that you can add these slots in the tube and then ensure that the plate that you're manufacturing has a tab and can fit in the slots so that your parts fit together cohesively. This is also a front plate, and you can see we will have holes and in the plate and then holes in the tube where we can put a riv nut, apply that after, and then assemble the complete part. All right, now we're going to take a look at the G code that we've generated for our chassis mount. So this is the vertical plate. In this example, we added a lead in, lead out. This is what the plate will look like. I'll just run through the path of the torch so you can see what it looks like. And this is our base plate. I'll run through the codes that you can see. First, it's going to cut the inner elements. There's an inset. I'm going to look from one of the side angles so that you can see the G code that's generated for the plasma table uses a torch height control, which has these G code paths that they're not easy to understand, but what it's actually going to do is drop the torch until it detects the metal, and then it's going to move up to a desired height. So that's why it's got these paths that won't actually descend into the part. Example, I can see the G code that was generated for our model. It has the features, and the other example, demo plate, has the other example that we made. The Jeep has a few exports, but we're looking for the plates. Here is an example of the part that we're using for the Jeep bumper. It has the holes for mounting to the chassis and the holes for aligning the tabs, and then the outside profile that matches the chassis of the Jeep. And here's the result. This was the prototype 3D printed stand for the chassis jig. They can be mounted in two directions.